All right. Section 5.4, example 4. These are going to be like the ones that we did last chapter. So we're going to have to first expand this using the cosine of a sum. And instead of writing arc sine and arc cosine, I'm going to write inverse sine and inverse cosine so I have less to write. So I have cosine of, this is my A and this is my B. Cosine of B. And then minus, because my signs are going to be different, sine of A and the sine of B. So we don't worry about domains, we don't worry about restricted values. So what's nice right here is this is equal to x, and this is equal to 2x. These are the ones that require a little more work, okay? So I need to draw pictures for both of those. For this one, it says the cosine of the inverse sine of 2x. Well, if I have an angle whose sine is 2x over 1, that makes this side, using the Pythagorean theorem, 1 minus 4x squared. So the cosine of that angle is going to be this over 1, or the square root of 1 minus 4x squared. For this particular one, if the cosine is x over 1, again using the Pythagorean theorem, this side is going to be 1 minus x squared, so the sine of that angle will be this over 1, or the square root of 1 minus x squared. And now, even though there's a little more work here and here, the nice part is we're pretty much done. There's nothing that you can multiply. These are not like terms. So I have x square roots of 1 minus 4x squared minus 2x times the square root of 1 minus x squared. And that ugliness is my final answer. Okay? So example 4b, we have the sine of a difference. So sine, cosine, cosine, sine. Again, this is my A and this is my B. So I have the sine of the inverse tangent of x and the cosine of the inverse cosine of 1/2 minus, same signs. Okay, this was a plus, this is a minus. On the last one, on this one, this is a minus, so this is going to also be a minus. Cosine of the inverse tangent of x, and then sine of the inverse cosine of 1/2. Squeeze it all in here. So, first thing we have, sine of inverse tangent. So I have to draw a picture. All right. So my tangent is x over 1. Pythagorean theorem, this is x squared plus 1. So the sine of that, we are going to get a fraction, x over the square root of x squared plus 1. That is not a perfect square. You can't take the square root of it. Cosine of inverse cosine of 1/2 is just going to give me 1/2. Okay. Cosine of inverse tangent, I get away with being able to use that same triangle again. So the cosine of this one is going to be 1 over the square root of 1 of x squared plus 1. And then inverse cosine of 1/2 is saying, where is the cosine 1/2? Well, the cosine is 1/2 at pi thirds, and the sine of pi thirds is the square root of 3 over 2. So unlike the last problem, we have a lot more cleaning up to do, okay? This particular one right here, I have x over 2 square roots of x squared plus 1. This one, I have a square root of 3 over 2 square roots of x squared plus 1. Now, what is nice is I do have a common denominator, okay? But I need to rationalize my denominator. So I have to multiply, and I'm going to just do both of these, the square root of x squared plus 1 over the square root of x squared plus 1, and square root of x squared plus 1 over square root of x squared plus 1. So this fraction becomes x square roots of x squared plus 1. This top, I have two radicals, so I get the square root of 3x squared plus 3. I'm going to multiply those. And then my bottoms, I already had a common denominator, but now, and I'm rationalizing the denominator in both, so I still have a common denominator. If I multiply those two, I'm going to get x squared plus 1, and then I have to distribute my 2, so I get 2x squared plus 2. So this one ends up being quite a bit more work than the last one.